Hi, this is Mr. Barron, and I want to show you how to balance redox reactions by the half reaction method. First off, what you're looking at is a handout that I plan on giving to you in class, and this handout can be currently found in the handout section of the website. It is titled exactly what the title of this worksheet is, which is Balancing Redox Reactions by the Half Reaction Method. I feel that this simplifies what's in the book to help you balance redox reactions. I'm going to be doing two examples for you. I'm going to start off with the first one that is actually going to be simple. So let's start off with one of the examples given in the book, which is Cu plus NO3 minus produces Cu2 plus NO2. All right, now let's refer to the handout. The first thing we have to do is it says write separate equations for both the oxidation and reduction half reactions. You don't have to actually know which is which. So what this means is if I see Cu and Cu, I'm going to write it out separately. So I'm going to leave myself as much room as possible. Cu changing to Cu2 plus, broken up that one. And then I'm going to break up another one, which is NO3 minus, and goes to NO2. All right, I'm going to start with the first half reaction. The first half reaction, let's look at the rules. The rules are balance all elements except hydrogen and oxygen. That means I have to make sure that I have the same number of coppers, and I do have one copper. Second, oxygen, I have to balance the oxygens using water. I don't have any oxygens, so I don't have to do that. Third rule, hydrogens, balancing the hydrogens with H pluses. I don't have any hydrogens, so I don't have to balance hydrogens. And the fourth rule is just to balance the charge. Well, on the right side I have 2 positive. So to get this 2 positive to be neutral like the left side, I'm going to have to balance out that charge with 2 electrons on the right side. Done with that half reaction. Now let's go to the next half reaction. Next half reaction, I have NO3 minus on the left side, and I have NO2 on the right side. First rule, balance all elements except for H and O. Well, my nitrogens are balanced, so I'm good to go on rule 1. Step 2, balance the oxygens. Well, I have 3 over here, I have 2 over there. I need to add 1 more oxygen to this side, and I can only add oxygens to the right side by adding water, H2O. Third step, now that my oxygens are done, I'm ready to start balancing out the hydrogens. Now on the right side I have H2Os. Since this is in an acidic solution, I have to balance out these H2s with 2 H2s on this side. But I can only add H2s on the left side as hydrogen ions, H pluses. Finish that now. Now I have to look at the charge. So on the right side I have no charge. That means I have to add electrons in a way that I can get no charge over here. So I have 2 positives and I have 1 negative. 2 positive plus 1 negative is positive 1. To balance that out, I need to put 1 electron on that side. Done. Now I have to make sure, this is the next step, I have to look at the 2 half reactions and I have to compare them. I should see the same number of electrons gained as lost. See how it's E minus here and 2E minus here? That means this needs to be 2E minus to show that 2 electrons were gained and 2 electrons were lost. Remember oil ring. So to do that, I'm going to have to put a 2 in front of here. But if I put a 2 in front of here, since you want to think of this as an equation like in math, that means everything else has to be multiplied by 2. So instead of having 2 H pluses, I now have 4. Instead of just having 1 NO3 minus, I now have 2. Instead of 1 NO2, I now have 2. Instead of having just an H2O, I now have 2 H2Os. Good. Now this is the way I like to do it. I like to compare the 2 equations and imagine these 2 guys. Here's my arrow, and I'm lining them up. I'm actually going to rewrite these 2 so it's a little bit more clear for you. So I'm going to take this half reaction, which I've now balanced, this half reaction, which I've now balanced, and I have to combine the 2. So I'm going to actually rewrite it. Here we go. Cu, arrow, Cu2 plus 2E minus. Then the other one, 2E minus plus 4H plus 2 NO3 minus. Arrow, 2 NO2 plus 2 H2O. Fantastic. Now what I have to do is I have to combine the 2 equations. So I have 2E minus on the left and I have 2E minus on the right. Imagine these 2 coming together and I add all the left and I add all the right together. If it helps you, you could actually write it out as 2E minus plus 4H plus 2 NO3 minus plus 1 Cu on the left side. but I'm just going to imagine that there's sort of this line going right here, and that all of these guys are on the left and all of these guys are on the right. So think of it as a division line like that. Now, I have two e minuses on the left, two e minuses on the right. That means that I can get rid of them. It's sort of like algebraically, I could subtract 2 and I could subtract 2 on the other side and they'd go away. Now I have to look and I have to see if there's anything else I can cancel out. And so far, I'm not seeing a whole lot. So let me write it out. I have Cu plus 4H plus 2NO3 minus arrow. So I've written all of this. Now I'm going to write these three down. Cu2 plus 2NO2 plus 2H2O. All right. So I take a look at it and I make sure that I have absolutely everything balanced out. So I have my hydrogens over here and I don't have any hydrogens over there, so I don't need to balance any of that out. And it looks fine. And that's actually the correct balanced. Continuing on, let's take a look, now that I've balanced that redox reaction, let's try and balance one that's a little bit more challenging. This is actually going to be C from one of the from one of the redox reactions I wanted you to balance as part of your homework. So this one, following the same rules, I have I2 plus OCl minus, arrow, IO3 minus, idate, plus Cl minus. All right, I'm going to break it into the two half reactions now. So breaking it into the two half reactions, I'm going to take the I2s, the I's, and separate them out. There's one half reaction. And then the other half reaction is going to be OCl minus to Cl minus. All right. Now, the first half reaction, what I'm going to do is I want to make sure that rule 1 is followed. Rule 1 says balance out anything that's not hydrogen and oxygen. Well, I have two hydrogens here. I only have one here. So to make it two, sorry, I think I said iodines, two iodines here, and I need to have two over here. So I'm going to put a 2 in front of there. Done that now. Next, on this half reaction, I'm going to follow the steps. I'm going to balance out the oxygens. Well, the oxygens I have are 2 times 3, so I have 6 oxygens on this side, so I need to have 6 oxygens on this side. I'm going to balance that out with a 6 H2O. Now, I have to balance out the hydrogens. Now I have 12 hydrogens on the left side, so I need to have 12 hydrogens on the right side. Atom as H plus is because my solution's acidic. Good. Now I have to balance out the charges. So, on the left side it's neutral. On the right side I see 2 negative, so this is negative 2, and this here is positive 12. Negative 2 plus positive 12 is positive 10. That means I have to balance it out with 10 electrons on this side to keep it neutral. So negative 10 plus 12 positive is 2 positive. 2 positive plus this. Remember, this is negative 2 because I have 2 of these negative ions. I now have a balanced charge, and I have the balanced hydrogens, and I have the balanced oxygens. Now I'm going to go down to the bottom. Bottom one, the Cl's already balanced. There's one Cl on the left, one Cl on the right. So I need to balance out this oxygen by writing an H2O over here. Alright, now I have the 2 hydrogens over here. That means I need to put 2 H pluses on this side to balance it out. Now I have to look at the charges. I have positive 2 plus negative 1. That's positive 1 on the left side. And I have negative 1 on this side. So the only way to make this negative 1 over here is to add 2 electrons. So negative 2 plus positive 2 plus negative 1 is all negative 1. And this side's negative 1. Good. Now what I'm going to do, since it's starting to get a little bit more complex, is I'm actually going to rewrite them. And I'm going to rewrite them so I have a lot more space to do some more manipulations. So I'm going to write out what I've done so far for the first half reaction, 6H2O plus I2, just copying down what's up here, arrow, 2IO3 minus, plus 12H plus, and 10E minus. Bottom one, it's 2E minus, plus 2H plus, OCl minus, arrow, Cl minus, plus H2O. Alright, now what I want to do is I want to make sure that these electrons are the same. The bottom one's not right now. I have 2 electrons right here. So I need to make this 10 so it looks like I have 10 electrons on the left side and I have 10 electrons on the right side. Whatever's gained needs to be lost. So I'm going to multiply this by a 5. If I multiply this by 5, it becomes 10. And if I multiply this by 5, I have to multiply everything by 5. So this becomes 10, 5, 5, and 5. Okay? Now I'm going to add those two equations together, all the stuff on the left and all the stuff on the right. I have 10e negative and 10e negative. They can be crossed out now because they can cancel out. Now this is the part where it becomes a little bit more tricky. I've crossed those out, so I'm actually going to rewrite all of this stuff on the left, producing all of this stuff on the right. So 6H2O plus I2 plus 10H plus 5OCl minus produces a lot of stuff. So I'm going to write it as close as I can to what it should be. 2IO3 minus plus 12H plus I'm just going to keep writing a little bit lower, plus 5Cl minus plus 5H2O. Okay, now let's start getting rid of these H2Os. See, I have an H2O over here and I have an H2O over here. See, if I subtract 5 H2Os on this side and 5 on this side, these H2Os go away, just like a regular algebraic equation. And 6 minus 5 is just 1 H2O. Good. So I've taken care of my H2Os. Now I'm going to look at the H pluses. I have 10 here and 12 there. Well, if I subtract 10 here and I subtract 10 here, they go away on this side, and I'm left with only 2 on the right side. So 2 H pluses. So let me cross out all the stuff that's here, and I've now written down here. So I've gotten rid of all of these waters, I've gotten rid of all of these H pluses, and I've written down the sum of all of them down here. Plus the I2, plus the 5OCl minus. Then over here, I can't forget this guy, plus the 2IO3 minus, and the 5Cl minus. This right down here on the bottom is your balanced redox reaction. If you guys have any other questions about this, if this becomes difficult, please come to tutoring.